The final way we have to solve quadratic equations is by using what's known as the quadratic formula. This is something that is not on your formula sheet, but it is a very, very useful formula. So I need you to memorize it. Like just every day, go look at it. I'm going to test you in class. But what our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, this is an important formula, and you should definitely have it written down. This is for quadratics that are in the form that we know really well by now, ax squared plus bx plus c equals 0, and where a does not equal 0. So a has to be an actual number. It can be positive, can be negative, it just can't be 0. Because if it's 0, it's actually not a quadratic equation anymore. We're also going to look at what the discriminant is and what we can use it for, and that is determining the number of solutions. So we'll figure out how we can use that to determine the number of solutions. Let's start with the discriminant. We often use this triangle sign to actually represent the discriminant, but all it is the part that goes under the square root in our formula. Oops, I can spell under the square root. So if we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, it is b squared minus 4ac. That is our discriminant. Okay, it's very, very simple. The way we use it to work out the number of solutions is that if the discriminant is less than 0, so if it is a negative number, there are 0 solutions. If it is equal to 0, there is 1 solution. And if it is bigger than 0, there are 2 solutions. Easy peasy. Here's 2 examples, and we want to know how many solutions there are to them. So our first one is x squared plus 5x minus 3. So we know a is 1, b is 5, and c is negative 3, because this negative belongs to the 3, because remember our form ax squared plus bx plus c. So if it's plus c here, it's plus negative 3. If we sub that into our discriminant, then we've got b squared, so we want 5 squared minus 4 times a, which is 1, times c, which is negative 3. So that's going to give us 25 minus 4 times 1 is 4, times negative 3 is negative 12, so 25 plus 12 gives us 37. Discriminant bigger than 0, so there's 2 solutions. Our second example, we've got a value of a of 2, b is negative 3, and c is 4. So we're going to have b squared, so negative 3 squared minus 4 times a, which is 2, times c, which is 4. So that's going to give us 9 minus 4 times 2 is 8, times 4 is 32. 16, 24, 32, yep. So 9 minus 32 gives us negative 23. The discriminant is less than 0, so there are no solutions. If we have one where it's equal to 0, we're only going to have 1 solution, because hopefully that quadratic will actually be a perfect square. So as you might have noticed when we were doing the discriminant, really all we're doing is working out our values of a, b, and c and substituting them into that formula. So if we're trying to solve x squared plus 5x plus 3 equals 0, we've got an a value of 1, b value of 5, and a c value of 3. So really, all we are doing is substituting that in to our quadratic formula here. So we're going to have x equals negative b, so negative 5, plus or minus the square root of 5 squared minus 4 times 1 times 3. And that's going to be divided by 2a, so 2 times 1. From there, really, we're just simplifying. So that's going to be negative 5 plus or minus the square root of 25 minus 12 divided by 2. So negative 5 plus or minus 25 minus 12 gives us 13. We can see from here, discriminant is positive. So we should end up with 2 solutions. So this means that x equals either negative 5 plus root 13 over 2, or negative 5 minus root 13 over 2. So we can write it in either form. Writing it in this form, totally fine, because we've got that plus minus in there showing us we've got 2 solutions, or you can write them out separately. That's also absolutely fine. All right, another example, we've got x squared plus 6x plus 9. So a is 1, b is 6, c is 9. So we are going to have x equals negative 6 plus or minus square root of 6 squared minus 4 times 1 times 9. Remember that square root, divided by 2 times 1. So we've got negative 6 plus or minus 36 minus 9 times 4, 9, 18, 27, 36. Square root of that over 2. Negative 6 plus or minus, we've ended up with the square root of 0 there. We remember from our discriminant, if it equals 0, there is 1 solution. So if we keep going here, we've just got negative 6 over 2. So our solution is that x equals negative 3. We can see at the start that was in fact a perfect square. So the fact that there's 1 solution makes sense. We could have just factorized that in any other way, but the quadratic formula will always work no matter what kind of quadratic that you have. Here's 2 for you to have a try at. 1 to find the number of solutions and 1 to actually solve the quadratic. Here are your solutions. So first one, no solutions because the discriminant was less than 0. Second one, if you got to 2 plus or minus root 52 over 8, that's fine. If you actually know how to simplify surds, you would end up with 2 plus or minus 2 root 13 over 8. If you don't know how to simplify surds, don't worry because we haven't actually been over that yet. So you might have a couple of instances in the answers for these where it's got simplified surds. If you're ever not sure, just let me know. I can clarify it for you, and we will go over simplifying surds at some point.